Hey folks, the Earthlings. Welcome to Decoding the Earth, the podcast where we dig deep into the layers of our planet to uncover the fascinating stories beneath our feet and sometimes even above our heads. I'm your host Raihan Ghani, a geologist and professor here to bring the rocks to life. Each episode will explore how geology shapes us by shaping the world around us. Ready to decode the earth? Let's rock. Today, we are diving deep, literally, into one of the most pressing and controversial frontiers in geology and resource extraction, deep sea mining. Beneath the ocean surface, at depths of 4 to 6 kilometers, lie vast fields of polymetallic nodules, potato-sized rocks rich in critical minerals like cobalt, nickel, copper, and manganese, which form over millions of years as minerals in the seawater slowly accrete around bits of organic matter or rock debris on the ocean floor. These metals are essential for modern technologies, from smartphones to electric vehicle batteries. The Clarion Clipperton Zone, a vast area between Hawaii and Mexico, is estimated to contain more nickel, cobalt, and manganese than all combined land based reserves. As the demand for clean energy technologies grows, so does interest in tapping into this underwater treasure trove. However, the legal framework governing deep sea mining is murky. The International Seabed Authority (ISA), established under the United Nations Convention on the Law of the Sea, is tasked with regulating mineral related activities in the international waters. Yet, as of 2025, the ISA has only issued exploratory licenses with no comprehensive regulations for commercial mining in place. Complicating the matters, the United States has not ratified the UN Convention, leading to potential legal conflicts. The metals company TMC, a Canadian startup, is seeking approval to commence mining operations, potentially bypassing international oversight. This move has sparked concerns about undermining multilateral agreements and setting a precedent for unilateral exploitation of shared resources. So, how exactly do you mine metals miles beneath the ocean surface? It starts with high tech exploration. Remote operated vehicles or ROVs are deployed from ships to scan the sea floor using sonar, cameras, and sampling tools. Once a site is located, often rich with polymetallic nodules, robotic collectors are lowered to the seabed to begin the harvest. These machines, like underwater vacuum cleaners, suck up nodules and send them up riser pipes to the surface vessel. Some newer prototypes even use mechanical arms to gently pick nodules, reducing disruption. The deep sea is one of the last understood ecosystems on Earth. Scientists warn that mining activities could have irreversible impacts on marine biodiversity. Sediment plumes generated by mining could smother habitats, and the removal of nodules, formed over millions of years, could disrupt ecological processes. Over 30 countries and numerous environmental organizations are calling for a moratorium on deep sea mining until comprehensive scientific assessments are conducted. They argue that the rush to extract these resources could lead to ecological disasters before we fully understand the consequences. As we stand at the very edge, what you might call the shelf edge, of this new frontier in deep sea mining, the decisions made now will ripple far into the future, balancing the demand for critical minerals we need to protect our planet's last unexplored ecosystem is a complex challenge. The deep sea holds both promise and peril. It is imperative that we proceed with caution, guided by science, international collaboration, and a commitment to sustainability. Thanks for joining me on Decoding the Earth. Next time, we'll uncover another fascinating topic. Until then, keep your feet on the ground and your eyes on the rocks. You never know what you might discover. Wishing you a happy Earth. A special thanks to Professor and Geologist Nahid Gani for directing and producing this podcast. Don't forget to subscribe and follow us on social media to stay up to date on all things geology. See you next time on Decoding the Earth.